Good morning. As you can tell, I've got a sore throat. I don't know sure what I sound like today. Anyway, we're talking about parametric equations. So first off, here we go. Let's find out about them. What are they? They're really talking about curves in such a way that we can track their path. So, and you can see here that we have a object that's going to travel at a 45-degree angle at a velocity of 48 feet per second. It's going to follow a path. And what we know is this: in the rectangular equation, here's one of our formulas: y is negative x squared over 72 plus x. But it doesn't tell us the whole thing about this particular problem with the parameter. It's possible to write things in what we call both x and y functions in t. Basically, we can follow the path of the ball, but we don't know how long it takes us to do that in this particular equation. So, our parametric equation, it shows x is this, as a function with t a time, and y is that. This will tell us where the ball is at any particular moment. The first equation just tells us the path of the ball. This equation tells us how fast it's moving, so that we can find x and y. It'll be this far out on x and that high up for y after so many seconds. Okay? And the result of that is what we call a plane curve. So, let's look at it. Basically, f and g are continuous functions of time over any interval for the ordered pairs, basically meaning you take in a sense f of x, g of x, except we're going to be talking about t, time. Plane curve gives a plane curve c. So here's what we know: x is equal to f of t and y is equal to g of t. And that makes the parametric equation. That's the definition. So what it means is this: let's sketch the curve given by this between negative 2 and 3. So first off, let's plot some points. If x is negative 2, if t is negative 2, x will be 0 and y would be negative 1. If t is negative 1, we just plug them in to get those particular answers. Alright? Now, if we plot them, it would look like this. I couldn't do a very good job graphing that one, sorry, but I wanted to show the points and what particular type of function it makes. So what happens is that that's an example of a parametric equation, because it will show you that it basically this is in negative seconds, which doesn't really happen, but after 1 second, these are the values that would be true for this right here. One would be at negative 3, meaning that if x is at the point, x is at when x is negative 3, the t value is 1. And also when y is at 1/2, when t is 1, we have it right. No. That's what you're saying. Here are our points: 0, negative 1, negative 3, negative 1/2, negative 4, 0, negative 3, 1/2, 0, 1, and 5 and 3/2. The x, y make our point after this many seconds. This is how we end up getting it. We put the t in, and it gives us the x and the y. But that's kind of the definition of a parametric function.